Here we have guided notes for section 2.4. We're going to solve equations with variables on two sides. Now, today during the activity, whenever we were up at the boards, I challenged you with one of these types of problems, and we did a pretty good job. But let's talk about it a little bit further and have some practice problems with it. When variables are on both sides, the goal is to isolate the variable on one side and the numbers on the other. Now, if I end up with 0 equals 0, then there are infinitely many solutions. If I end up with 0 equals a number, then there's no solution. And we'll talk about that here in a little bit. Mind you, the big goal with all of this, or the big understanding here, is that we are going to combine like terms. I want you to write this term down. I want you to write combine like terms. And then what I want you to do is I want you to put big stars next to it. And let's put a smiley face here. I'm going to make a smiley face. So I should see combine like terms on your paper when I check your work, and I should see 2 stars and a big smiley face. And I want every single one of you, I want you to show me your smiley face when you come to class tomorrow. In fact, how about this? The first 10 people, and now mind you, this is first and second period that are watching this video, so the first 10 people tomorrow, starting at 7:30, the first 10 people tomorrow to show me their smiley face on this page, I'll give extra credit. So I'm going to have extra credit if you have a smiley face on this page. And you can tell me what it means to combine like terms. So it's two-parter. I want to see your smiley face and your ability to combine like terms. Okay, so let's practice this problem here. So I have 5x plus 2 equals 2x plus 14. Now, for me, I always look to see what variable has the larger number because I like positive numbers with my variables. So positive, well, we're going to call these coefficients. The number that's being multiplied by the variable is called a coefficient. So here I have 5x plus 2 equals 2x plus 14. I want to subtract 2x from both sides. When I take 2x away from both sides, I'll end up with 5x minus 2x to get 3x, and I still have plus 2 equals 14. And now I can take 2 away from both sides, and I'll end up with 3x equals, oh, not 7. No, that's not it. 2x equals, or 3x equals 12, excuse me. And now I'm going to divide by 3, and I end up with x equals 4. And we can check our work by taking that 4 and plugging it back in here, right? 5 times 4 is 20. 20 plus 2 is 22, so I'd end up with 22 over here. And 2 times 4 is 8. And 8 plus 14 is 22. So yeah, it works. So I'm going to put a little check mark. I did a little check. It was really rough and it was very quick, but that's what you could do. You could plug the number that you found in for x and plug it in. Now, mind you, I want to see your work. I want to see the steps that you take from one line to the next. If I don't see that, then that tells me that you know how to find an answer, but you don't know how to get to that answer. So if I don't see your steps and I don't see this work, you will get knocked off or points taken away for that. So make sure on an exam or quiz or your homework that you're showing all the steps. All right, here we're going to have another problem here. 2x plus 7 equals negative 1 times the quantity 3 minus 2x. And since I have this negative 1 here with these parentheses, and inside my parentheses, these are not like terms. 3 minus 2x, these are not like terms. So what I need to do is, to get rid of these parentheses, I'm going to take this negative 1 and distribute it to both terms, that guy and that guy. So negative 1 times 3 is negative 3, and negative 1 times negative 2x is a positive 2x. And that didn't do anything to the left side yet, so I have 2x plus 7 equals negative 3 plus 2x. And now if I want to get my x's onto the left side, I'm going to subtract 2x, and I subtract 2x, and I get 7 equals negative 3. Wait a second. That doesn't make a lick of sense, because everybody here knows for sure that 7 is not the same thing as negative 3. So here I will say this is no solution. And if we really want to go a little bit further, if we add 3 to both sides, it would say 10 equals 0. So again, if you get 0 equals a number, it's no solution. All right, let's try this problem out. It looks like we're going to have to distribute again first. So I'm going to take this 4 and distribute it to both terms, and I'll end up with 8y plus 4. Right, so that goes to both terms. And that's equal to, and I'm going to distribute my 2 to this one and that guy. So 2 times y is 2y, and 2 times negative 13 is negative 26. Now, since 8y is bigger than 2y, I want to get all of my y's. I'm going to combine all my y's to the left-hand side. So in order to get rid of the 2y, I have to subtract 2y. And here I'm going to subtract 2y. And that'll leave me with 6y plus 4 equals negative 26. And I'm going to subtract 4 because it's the furthest thing away from that y there. And I get 6y equals negative 30. And dividing by 6 leaves me with y equals negative 5. All right, for this last one, again, we're going to have to distribute because of these parentheses. So 3 times 4b and 3 times negative 2. So 3 times 4b is 12b, and 3 times negative 2 is negative 6. And that is equal to negative 6 plus 12b. Now I can add 6 to both sides because I want to get rid of it over here. And negative 6 plus 6 is 0. And I want to subtract 12b from both sides. So that goes away, and 12 minus 12 gives me, oh no, I have 0 equals 0. And in this instance, there are going to be infinitely many solutions. And this is the answer that I would like to see. 0 equals 0 is okay, but what does it mean? It means that there are infinitely many solutions. So when you get a problem like this and you end up with 0 equals 0, I would like for you to show me infinitely many solutions on your paper.